Hey everybody, welcome to Bill Sky, the Assembly Guy, and we're going to start our discussion today with functions. How do we actually create a function in assembler language, and how do we use it? We're also going to go over how to set these functions up externally so we can link those functions into any assembler language program that we write. So we're going to be just generating an object file. And now, let me just say, this is going to be your introduction to functions. It's not going to be the quote-unquote right way to write functions, but it's a way to get started. And then when we start talking about stack frames in a few videos from now, we're going to go ahead and show you the right way to do it. So we're going to do this on Windows, we're going to do this on Linux, and we're also going to do this on ARM RISC processors. And those will all three be separate videos, so the videos aren't just huge, okay? So anyway, so let's get started with simple functions in assembler language. All right, so here we are on Linux, and I'm going to do this one a little bit different than I did on Windows. So it might be a good idea to look at both the Windows and the Linux versions of these videos so you can see the differences. But I'm basically going to be going backwards from the way that I did the Windows one. So what we're going to do is we're going to do some functions that are inline to our main. Then we're going to convert those to external library functions. And you're going to find it's a lot easier under Linux. So let's go ahead and create a project. And I'm going to call this Linux 64-bit functions. And let's go ahead and create a simple little function. I'm going to open up my main.asm file, make it a little bit bigger here. And down below the very last line of code, I'm going to create a function. Now, the way that you create a function in Linux is that you don't have to create a proc line or an endp line or anything like that. All you do is you give it you give the function a name. So just like in Windows, we're going to call this one add2, and that's it, with a colon at the end. And that's it. And normally you will always return, and then I always like to put a comment so I know where the end of the function is. Now, the other thing is a good idea to do is to put in what the inputs are to your function in comments, what the return value is, and where is it located. You might even want to put a description. You might even want to put an example. And this is all part of the design of the function. And also in assembler, functions are not as easy to understand by just looking at the function definition line. So it's always a good idea to have this. So for instance, for inputs, I'm going to say EBX and ECX are arguments. The return value will be the sum of EBX and ECX in EAX. And now this is 64-bit, so we have to change all these E's to R's. And then the description, this function will simply add two numbers and return the sum. And then for example, you might want to do something like move EBX comma 10, move ECX comma 20, call add 2. That's simple. You show the user how to do it or the programmer how to do it, and we're all set. Okay, so this function's really doing nothing right now. Let's go ahead and save and build it. So it looks good. And we can go ahead and call it. Now, it's not going to do anything, and this is what's really nice. I'm going to copy the example code that I put in the comments, uncomment them, build it, and okay, it looks good. Now, it isn't doing anything. We could debug it at this point, but you know, it's just not doing anything. So let's go ahead and add the code to do it. So it's very simple. We're going to move into RAX, EBX. We're going to add to RAX, ECX, ECX. And I think that's it. That's all that function does. Pretty simple function, right? All right, so let's save and build this. Okay, now, problem. I don't know why I'm having 32-bit and 64-bit issues here. So I've got to really get my act together here. 64 bits, so all these have to be R's. Well, they don't have to be, but it's always good to do it that way. All right. So now let's go ahead and debug this. So I'm going to kdbg main. And we're going to make this real simple. I'm just going to put a breakpoint on the no-op right after the add to and run it. And you can see right here that RAX has 30. So it worked. Now if you really wanted to see it execute, put a breakpoint on the no-op and run it. Step over, step over, step over. And now we want to go into the function. So I'm going to press step into. We're in the function. It adds the things together. It returns. And so you can actually see it execute. So you can do that with just about any kind of a function. And you can put the arguments inside of registers. Now the problem with that though is that if your main function, if the main part of your program is using RBX and RCX, and you're using them as arguments, which is okay, it's not the real right way to do it, and we're going to talk about that in an upcoming video on stack frames. But if you really want to do that, it might be a good idea to back up those registers before you use them. So you can push RBX, you can push RCX. So what we're going to do is we're going to back up our argument registers. And then when you're done, you're going to pop RCX, and that's going to be restore our argument registers, and pop RBX. So by using the stack, we're backing up those registers, and then we're filling them with data to go to the function. We're calling the function, then we're restoring those registers. Now, another very common practice is to do that backup inside of the function. But the function isn't modifying RBX and RCX, is it? No, it's just modifying RAX, and I'll mention why in just a moment. So really, the function isn't doing anything to RBX or RCX, so it wouldn't make any sense to back it up there because my main function modified those values. So why back up something that my main function did? Let the main function worry about it. So the function that is modifying the registers should be the one that's responsible for backing them up. And in this case, it's our main. Now I mentioned a moment ago about RAX. RAX is considered it is called the accumulator register, but it's also the return register. Whenever you call a function in C or C++, and that function returns a value, the underlying mechanism for doing that is that it puts the return value into RAX in this case. If it's 32-bit, it'll put it into EAX. But in this case, 64-bit, it's going to put it into RAX. That's how values are returned. That's why you can really only return a single value from a function call. Now, if you want to return multiple values from the function call in another language like C or C++ or Java, you can make it an object or you can make it a structure. But we're not going to do that here today. So just remember, RAX, it is assumed that RAX is going to be modified by any function that you call. So if you need to back up RAX before, you might want to do it here. Now, one thing you have to be careful though is that if I pop RAX, I've just overwritten what the function produced, what the function changed RAX to. So you have to think a little bit about this, about how you're going to back up your registers. And maybe you do something with RAX and then you pop it, but you have to be careful. So you have to think about this. So there is a certain amount of, I don't know what I want to, design when you're doing these kind of functions. So that's an inline function. That's what I call an inline function. The function is actually part of my main source code, my main project. So now let's take that function, let's move it out. Let's move it out of my main. Because why? Because I would like to put that function into a library that I can use in many of my projects. And if you've downloaded the Komanetsky assembler language functions, you can see that everywhere. I have object files that you link. You don't have to see the source code, and you don't have to reproduce it in every program. You just use the object file. So to do that, I'm going to create another, just kind of give you an idea of why you would want to do this. I'm going to create another function just called subtract2. Subtract. Okay, the difference of RBX and RCX. All right, so let's go ahead and sub 2, and we'll move, and then we'll subtract RCX from RX. So there you go. So now we've got a couple. And if you think about it, if you have like 30 or 40 functions that you use throughout your code, why not just put it in an object file? I mean, that's the whole point of this. So the way to do that, and I'm going to do this all from Genie. It's going to be pretty neat. I'm going to create a new file, and it's just an empty file. And I'm going to go ahead and I'm going to copy these two functions. In fact, I'm not going to copy them. I'm going to cut them out of my main, and I'm going to put them into my untitled file. Now, the other thing I'm going to put in there is I could have copied the whole thing and then just got rid of the start. But I'm going to go ahead and copy and paste this. Now, why would you need a data and a BSS section? Well, if you have variables that your functions are going to use that you don't want anybody outside to use, then you can create your own variables in here. So like I could create a temp defined byte t. Now that variable temp, all of my functions inside of my new source file will be able to access it, but main.asm will not. So it's almost like it's a working area that your functions can use, kind of like a global set of variables for your functions only. So you're kind of encapsulating that shared data into this program. Okay, that's great. So now we want to save it, so I'm going to save it, and I want to save it. Now, unfortunately, on Genie, it didn't take me back to where I was, so I kind of have to find my way there. There it is. And I'm going to call this file some functions.asm. And now, because it has a .asm at the end, Genie knows how to parse it and color everything. Now, we're almost done here. We have to modify the makefile because we have to build this separately from the main and then link them together. So to do that, I'm going to click on the open button and I'm going to bring up the makefile. So you can see right here we are assembling the main, but we never really assemble the sum functions. So I'm going to create another makefile recipe, and I'm going to call this sumfunctions.o. Main is dependent on sumfunctions.o, so there you go. And sumfunctions.o is dependent upon sumfunctions.asm existing. And instead of main.asm, the assembler statement is going to be sumfunctions, and the listing file will be sumfunctions. And we might want to also, in the clean, remove sumfunctions.o and remove sumfunctions.lst. So our clean will deal with that. We're not quite done yet. So now our project, when I run the make, it's going to say, fulfill the recipe main. Main is going to say that it has to fulfill main.o. It's going to see that main.o needs main.asm. So if main.asm exists, it's going to assemble main. Then it says that it's dependent upon some functions.o. So it's going to come down here, make sure some functions.asm is existing. If it is, it assembles that. And then once these two requirements or dependencies are met, then it's going to link them. The problem is we haven't actually included the sumfunctions.o in the link statement. So let's go ahead and add that. And we're done. That is our make. So I'm going to save. I'm going to go back to my main and I'm going to build. and we still have problems. So it says add to is not defined. So we have a couple of problems. The assembler, we don't really have a prototype for the assembler. I mean, for add to, we haven't actually done that yet. So what we need to do is we need to go into our main program, and we need to specify that add to is external. Now, how would we have done this in Windows? We would have said add to prototype. I actually like that a little bit better just because, you know, function prototypes in C and C++, but I think the extern verb is more descriptive. It's external to this main. Okay, so let's go ahead and build it now. Okay, so it can't, we have a problem. Some functions.asm 30 and 16. Oh, did I make another mistake here? So 16, oh, I named these the same. I don't know why. Okay, oh, because I copy and pasted them, that's why. All right. All right, great. So, but now the linker says it can't find add to. So the compiler or the assembler, the assembler said it couldn't find add to because we hadn't said it was external. And oh, by the way, we also have our sub2. We haven't used it in our main, so that's why we didn't have an error. But that's also external. But the assembler can't see add to. And the reason for that is that in some functions, we did not specify that sub2 and ab2 were supposed to be global. In other words, everybody in the universe would be able to see them. So if I take the global sub2 away, that means that only functions within my sumfunctions.asm file will be able to see sub2, or I can leave it there, and that way everybody in the universe will see it. And now it builds okay. Now if you take a look at the build, it shows that main is assembled, some functions is assembled, and then main.o, some functions.o are then linked in the executable main. So there you go. So now we've got our external functions. Now what can we do with it? Well, I can take this, where is it? Some functions.o, I can put that into a folder. Let's say, so I'm going to right click on that and say copy. I'm going to go to ASM projects, and let's say I want to say, I don't know, my libs. And now any one of my assembly language programs can link to that. And you just specify the directory location of where it's located. So that's pretty neat, right? I never have to mess around with that again. The functions are there, just like the Komanetsky functions or the Irvine functions for Windows. If you're using that book during this course, they can, you know, you just use those object files. All right, great. So let's go back in there. So let's go see how this works. So I'm going to kdbg main. Okay, we're going to start it running. We're going to step over, step over, step over. Okay, now we're going to step into, and there's the code for add to. Now the reason why we were able to, it was able to show the source code is because some functions.asm is actually located in the same folder as this project. So if it wasn't, I would probably have to say open source code and navigate to where that some functions.asm is located, but because they're both all located in the same directory, then it finds it no problem. And you can just watch EAX or RAX in this case, and then it returns. All right, now, one last thing to make this really complete, and that is to create an include file. My main should not have to say, oh, actually, I'm on the wrong one. My main should not actually have to say this extern, right? It just shouldn't have to do that. So to make this work, I'm going to create a new file. And this one I'm going to call, and let's, well, we don't have anything in there. So let's go into my main, and I'm going to cut those out and put them in here. And I'm going to save it, and I'm going to call it, again, Genie didn't take me back to where I was. So I'm going to go into there, and I'm going to call this one sumfunctions.inc. It's always good to make your include file or your header file the same name as the object file. That way that there's no confusion. So I'm going to go ahead and save, and there's SumFunctions.inc. I'm going to close that. There's my main. Make sure I save it. Now I'm going to try to make it, and we've lost add to again because we got rid of those externals. So now what we have to do is we have to do an include. So %include SumFunctions.include. I'm going to save and build, and it builds again just great. Also notice it only built the main. It didn't bother building the SumFunctions.asm because that was already up to date. We had not made any changes. So what does this mean? This means that you need to put the SumFunctions.o and the SumFunctions.inc into the mylibs. So I'm going to copy this, go back, and paste it. Now, I don't have to have those in the mylibs directory from this project. And the reason is because I've got everything in the same directory. However, if I create another project, I don't have to worry about SumFunctions.o or SumFunctions.inc because I put them into the mylibs directory. All I have to do is modify my makefile to go look for them in there. You know something? Why don't we go ahead and do that real quick? Let's go ahead and do that. I'm going to create, so I'm going to close this project right here. And I'm going to go ahead and create another project. And I'm just going to call this one test because we're going to get rid of it. And I'm going to go in there. Now, I know that I've already got a good makefile here in the project that we've been doing in this video. So I'm going to copy that. I'm going to go into my test directory and I'm going to paste it and overwrite it. And I'm going to edit. Now inside of the makefile, I've got pretty much stuff there. The problem is that I don't have some functions in the same folder. So I have to tell it where to go. Now to find some functions. Now if you remember, it's a directory above test. It's inside of my libs. So what I'm going to do is I'm going to say that file is located in dot slash mylibs some functions. And you want to do this, yeah, that's how we do it. And we don't need this build anymore for some functions because we are, it's already pre-built. So I can get rid of this dependency of SumFunctions.o. Okay, here's my new main. I am going to need the include, so I'm going to say %include, and that include is going to be /mylibs /SumFunctions.inc. Now remember, the dot means go up a level. So in this folder right here, we're in test. That's where our assembler language program is. So dot means go up a level, which takes me to ASM projes. Then mylibs. Then you find SumFunctions.inc. So let's go ahead and make this. Worked great. Okay, notice it didn't have to assemble some functions because that's a provided object file. And SumFunctions.inc, that's got the externs. So let's go ahead and put some code in there. I'm going to move and do, I think it was RBX20, move RCX30, call add to. Let's save and build. Wow, it worked. So let's go into the command line or the terminal. Oh, nope, I'm in the wrong directory. I got to be in test. There we go. It's KDVG main. Now this project looks a lot like our first one. So let's put a breakpoint on line 13. Step over, step over, step over. Now this is where it's going to get a little interesting. I'm going to press step into. And it found it. That's awesome. It actually found it. And that's probably because it statically linked it, it attached it to my executable, so it had all that. So every project I have now, I can just %include and change the link, and it works great. Okay, so that's our example of simple functions in Linux, and hope to see you at the ARM video.